So we're doing prototype number one, and prototype number one is it's an education tool where we can show the load current sine wave for the conventional coil that we'll be using to power this light bulb, and we'll be able to monitor the output. And the ReGen-X coil that's wound on the same core, there's actually two of them. When we place the ReGen-X coil on load, when we place the conventional coil on load, we'll be able to see the load current sine wave for the conventional coil. And then when we place the ReGen-X coil on load, we'll be able to see its load current sine wave and its delay. And the yellow ReGen-X coil produces a 50-degree load current delay, and the green coil produces a 90-degree load current delay. So the load current delay needs to be about a minimum of 45 to 50 degrees, but it can be shifted, okay? And both loads are identical. Both loads are purely resistive loads, which means that the voltage and current sine waves are in phase, okay? So when we're looking at the current sine wave on the oscilloscope, that's also the voltage sine wave. So, So, same scenario with this as with this. We bring the system up to rotational equilibrium. You can actually squeeze in here, and you're welcome to come closer if you want.
So this one is drawing 75 watts right now?
It's gonna drop once. So right now we're going up here. And then it's going to start to head down towards here. So what we want to make sure is we're operating in this region, not this region. So again, we're somewhere here, and that's the horsepower curve, that's the power curve, that's the torque curve, and this is the current. So if the current goes up, the power goes up, and the torque supplied by the prime mover goes up. If the current goes down, which is here, then the torque supplied by the motor and the power, mechanical power supplied by the motor is going down. And so what we'll see with the conventional coil is this number is going to go up. The prime mover is delivering additional mechanical power to the drive shaft, and in order to supply the power to the load, and then when the ReGen-X coil is placed on load, this number is going to go down. And in fact, the ReGen-X generator is going to require less input from the prime mover while it's delivering more power than the conventional coil. It'll be using less power than it is on load than is required on idle. So with a conventional generator, whatever we take here, 9 watts or 10 watts or whatever it is, that has to be supplied back to the prime mover, and we need at least, for the conventional generator, we need at least 9 watts of mechanical power increase in our drive shaft. And with the ReGen-X, so we'll just take a note of where we started. Watts per prime mover. Again, we're at rotational equilibrium. The mechanical power in the drive shaft is 0, and the drive shaft doesn't have any ability to perform any additional work. Now the prime mover is consuming more power, delivering additional mechanical power to the generator's drive shaft, and this is the low current sine wave for the conventional coil. So 0.89 amps through our load. So our input to our prime mover is less than what we started with. Our output across our load has increased. And from here to here, that's 90 degrees on the sine wave. And we're about 45 to 50 degrees low current sine wave delay. Let it go on. And now we're about 90 degrees. And the input has gone down a little bit more, and the output has gone up slightly as well. So what we have with the sine wave is from here to here, we have the north pole. The low current sine wave for the conventional coil establishes the physical position of the rotor magnet to the core. So from here to here, we have a north pole magnet that is approaching the coil's core at top dead center. And from top dead center to here, we have a north pole magnet that's moving away. From this point here, which is called the node, to the trough here, we have a south pole that is now approaching the coil's core, and from here to here, we have a south pole that's moving away. So 232 watts to the prime mover. $213, $212 to establish rotational equilibrium. Our prime mover is consuming about 8 watts less than the conventional coil. Now, at top dead center, what we have is the north pole magnet is now starting to move away from the coil's core. But the ReGen-X coil it's still producing a north pole repelling magnetic field that now is basically assisting the north pole magnet's departure away from the coil. And it doesn't peak until here. So from here to here, it's producing a complementary torque, and conventional generator coil is always producing a counter electromagnetic torque, and the ReGenX generator produces a complementary electromagnetic torque which accelerates the rotor and reduces the prime mover's consumption. Okay.
These are all brushed,
No, these are all,
right?
that's AC, this is DC. We're using a bridge rectifier to convert it to DC, sending it to our battery. And the prime mover is AC, and the prime mover on top is AC as well.
So the inputs are AC motors. Prime movers are AC.
Yeah. And this one is DC. Okay, so same scenario that we saw basically here. This is the test bed where I basically changed the configuration of the coils, test them out on here, and then put them in the e-bike, and to basically maximize performance in the e-bike. So in this, again, what we're going to do is bring the system up to 30 kilometers an hour, and we have 3 ReGenX generator coils here.
Which ones are those are the 3?
I'm not sure. I think these 2 are going to be quantum motor coils, and I think this one and one of those is going to be a ReGenX coil, and
And the difference being just how they're electrically connected, or?
okay, the ReGenX, the regenerative acceleration coil, that's connected through a bridge rectifier to the batteries. So what you're going to see on here is the magnitude of current that I'm delivering to the batteries, okay? And these coils all create acceleration. And whereas I purposely made some of those create deceleration so that you could see, that if you put a conventional coil in there, it's going to decelerate the system. So on here, we can monitor.
Physically, is there a difference between the different coils?
No.
It's just how they're connected.
Yeah, the ReGenX generator coil is connected to the battery through a bridge rectifier. The quantum motor coil is just a ReGenX generator coil that's shorted out. So again, what you experienced here, so everything that I'm showing you with the ReGenX generator and the ReGenX quantum motor coil, what you experienced here was a dead short and maximum resistance on the drive shaft. What we're demonstrating is a dead short and maximum acceleration, maximum assistance on the drive shaft. And then the ReGenX generator connected to a load, the current through the load is slightly less than it is here. The so the regenerative braking aspect is going to be slightly less. And the regenerative acceleration aspect is going to be slightly less. So in an EV, what you guys are going to do is once this is in an EV, if we had 12 coils in here, for example, it's designed to have 12 coils. So the coils will be motorized initially, just like the original drive motor, and they will help propel the EV up to cruising speed. Once up to cruising speed, and this is where a CPU will be used to dictate the function of the coil. Once the EV is up to speed, depending on the driver input, road conditions, and all that sort of thing, the CPU will decide the function of each individual coil, from motor operation to regenerative acceleration operation, ReGen-X quad motor operation, or regenerative braking, depending on the driver input and the road conditions, in order to maximize the efficiency of the e-bike. So again, if the driver is just cruising down the highway at 100 kilometers an hour, and he doesn't need, you have all the inertia built into the EV. Now, all of the ReGen-X coils in the ReGen-X motor can be converted to regenerative acceleration coils. That means they're recharging the battery and accelerating, and recharging the battery and minimally not decelerating the EV, unless the driver puts his hand on the brake. Then the CPU will decide the number of coils that are converted to regenerative braking coils. So the CPU, once this is in an EV, the CPU is going to dictate motor operation, regenerative acceleration operation, a combination of what I'm going to do here. Through playing around, I've found that if I have one coil in quantum motor coil in motor operation and these two, it seems like I get the best performance right now. So that's what the CPU is going to be basically deciding once this is in an EV. What's, number one, what's the driver input? Number two, what are the road conditions? Number three, what's the best operation for the coil under these conditions? Not just the coil, but each individual coil, and then the combination of all the coils.
So how will a CPU detect the road conditions? Or the environment?
Yeah, okay, well, so the driver input is the key.
Mm-hmm.
If the driver if there's a strong wind in front of the car, the driver's going to basically be asking for more acceleration.
Okay.
The driver is going to dictate what function the coil is. If the driver is just like on cruising speed, like you're going to see here, then the coils are going to go into regenerative acceleration mode,
Okay.
where they're going to, I'm going to say accelerate the EV, but not noticeably, not like 10, 20 kilometers an hour. It's going to recharge the battery and not decelerate the car, which means that the input requirement from the driver is going to go down slightly. On here, what we saw about 450 watts in our prime mover at idle, and then it went down to like 170 or 190 or whatever it was when all of the coils were in quantum motor mode. So again, it's a,
So you have, like, your special coils are multi-purpose, or are you using different kinds
absolutely,
of coils?
absolutely. Every single coil has at least 4 functions.
Okay.
So a conventional coil in a conventional DC motor has 2 functions. Motor, if it's in an EV, motor mode or regenerative braking mode. That's it. So with this, you have motor mode, you have regenerative acceleration mode, you have quantum motor mode,
Okay, so what changes in your coil to give you those different modes?
the frequency of operation,
Okay.
and the number of turns on the coil. And I'm going to get to that.
But you can't program the number of turns in the coil.
So what you do, this is the coil's core. The first coil is 0.1 ohms, okay? That's a conventional coil.
Okay.
And these are the outputs.
So you're selecting different outputs on the coil.
Yeah, it's a multi-tap coil. So 0.1 ohms is a conventional coil. If you measure the DC resistance of this coil, it's about 0.1 ohms. Okay, so that's going to give you the best motor coil operation.
Okay.
It's also going to give you regenerative braking at any speed. Okay, and the CPU is going to ensure that function. Okay, now once you're up to cruising speed, the CPU will connect in series this 0.1 ohm coil to the 0.3 ohm coil, which is the ReGenX coil.
Okay.
Now you have a 0.4 ohm ReGenX coil. Okay, one of those, the number 3 coil that I showed you there, that's 0.3 ohms. The other coils, and it produced regenerative braking, and I can show it to you again.
Okay.
So I can show you everything again. That coil is 0.3 ohms. The other coils that produce regenerative acceleration are 0.4 ohms. So that's the difference. At the same speed, 0.1 ohms dictates regenerative acceleration or regenerative braking. And also the frequency of operation of the 0.3 ohm coil. You can get a 0.3 ohm coil to go into regenerative acceleration if you increase the frequency. Okay, so there's different parameters.
Now, how do you, like, the frequency is dependent on the speed of the motor?
Speed, yeah. So the frequency of operation is dictated by the number of poles on the rotor and the speed of operation. So let me finish this, okay?
Right.
So once you're up to speed, the CPU says, okay, we don't need this motor, we don't need any motor coils, or we don't, if there's 12 coils,
Okay.
maybe we need 2 in motor mode, and the rest can be regenerative acceleration coils. Recharge, sending some power back to the battery, and then, or if the driver is, or quantum motor coils. So this 0.3 ohm coil, which you saw in there, that's number 3,
Yeah.
can be shorted out to produce a quantum motor coil, maximum acceleration.
Okay.
But, and now I put another one up here, but
Now, do they have the 0.3 and the 0.4? Do they have a different phase delay, or are they the same?
they're this. Let's forget about the 0.4. You don't.
Okay,
I put
alright.
this, but you don't. That was
Fine.
early. You don't need 0.4 because you have this one, which is 0.1, and this one, which is 0.3. That gives you regenerative acceleration. And then without this one, now you have a 0.3 ohm coil will give you quantum motor operation.
Okay.
So EV acceleration, no input to the coil, and the best performance. And again, the CPU is monitoring basically the driver input, and again, the CPU will decide, you know, best case motor operation, and then the selection of what's going on here. Okay. So basically, this is just pretty much this in there, and we're using, actually you want to start it